Hello, this is MakerJ11, and today I'm going to be showing you this project which I'm testing out in LED. I'm finally getting around to recording it. I finally finished my tests and things with it. Today's featured subscriber is Bake Up CPU. He's a really cool guy. He does a lot of things with LEDs, and especially with he's been doing a lot of projects with Arduinos. He's got a lot of neat projects over there, so please go check him out. He also does a lot of sort of like Joule-y sort of videos, or circuits. He builds all kinds of weird circuits with just a couple transistors and an LED and some things like that. It's really cool. So yeah, go check him out, and there'll be a link in the description of that. But here's this. This is basically a pulse width modulation circuit, same one I used on my LED light bulb. It's basically got a 5-5 timer here, and then a amplifier chip here. This is actually a 4556D, and it's just some general dual amplifier. These are actually two others that I tried, but they didn't work as good as this one. I was just kind of trying random amplifiers. So basically that signal, this is the pulse width modulation trim pots here, and the frequency. It's set at about 7.5 hertz, something in that range. And then it goes to this MOSFET here, which switches the power on and off to this LED. And this LED is in a little box here, which has a solar panel in it. And it actually goes through this little 10 ohm resistor here, and I have my scope connected up across that so I can get the current. And then I've got the output of the solar cell, or solar panel, sorry. So I think it's a 3-volt solar panel. Goes into a 100 watt or 100 ohm resistor, and I can figure out the current off of this. So, and I was measuring the voltage across here, but I found that the current seemed to be more meaningful, so I decided to go current. But there's the scope shot. Let me turn the duty cycle down here a little bit. It went up, but I have the whoops. What did I just do? I think I might have just popped my LED. Yes, I think I just burned out my LED, which I've burned out quite a few already, so let me turn that down. But it's actually pulsing with 29 volts, which is quite a lot, and I was actually pulsing with 1 amp there. So these LEDs bought these off of Amazon. They were $15 for a bag of this, which is actually, then after I bought these, I looked on eBay, and you can buy a bag like this of 100 for like a lot cheaper. So go buy them off eBay instead of Amazon. They're a lot cheaper. But these are, you can see the specs on there. 20 milliamps is the current, the rated current. But I'm driving it at 1 amp, which is a lot more than they're supposed to be driven at. But it's only for about 50 microseconds that I'm actually driving it. So let me turn that down a little bit more, or else it'll burn it out. So we have to adjust that duty cycle there, so it's about 50 microseconds, or else it'll not be too happy. So I only have it at, I've adjusted my units on my scope, which you can do, that's really nice, so that you can get the units to actually display amps. So I have it on milliamps there, so I don't have to remember all of the units and everything. I have it all set up with the resistor so it displays the right value. So that's about 5 nanoseconds right there, or 5 microseconds. It's on, I'm not really sure exactly what that means, why it says nanoseconds, but each division is 10 microseconds there, so it's about 50 microseconds long of a pulse there. So right now let me crank the amps up here till we get about 1 amp. So I just have my power supply hooked up here. So I'm just going to watch the amps there till it's 1 amp. Okay, so that's pretty close. Alright, so there we go. We've got 1 amp. So that's 1 amp on the current side. So that's coming off this resistor. So there's 1 amp going into here at the peak there. And then the second channel, wait a minute. What did I just do? Oh, sorry. Okay, this is the amps. So the amps going into the LED. So we've got 1 amp there, and as you can see, it drops off a little bit, not a lot. And then the second one here is actually the output of the solar panel, and that is at 5, almost 6 milliamps there. And as you can see, there's a nice big spike there. That's where I'm measuring it, is at that spike. So it goes down almost half there. And that is because it heats up. The LED, that's when it's cold right there, because it's actually off for a long time. As you can see, I have to go all the way down to a lot, so you can just barely see the little spike there. Okay, there you go. You've got 2 on the screen there. So that is, when I do it down far enough, I can count about 17 on the screen, or I have to turn the duty cycle up in order to count how many, what the frequency and everything. So it's a very, very, very low duty cycle, probably less than 1%, probably way less than that even, maybe 0.1% duty cycle, which is really low. So basically, so yeah, okay, so the LED is putting out a lot of light right there, at that peak, but because the heat can't be, the heat from the LED can't be dissipated away fast enough, it heats up, and if that went on too long, if I made that pulse too long at 1 amp, it would just burn it out instantly, pretty much. Probably right here it would last for a little while. I'm not sure how long it would last. Usually when they burn out is actually when I accidentally turn up the amps too much, or the circuit has a glitch or something, and it'll turn on too long, it'll just fry it. But here's my sheet here of the things I figured out, my calculations, well, more so just recording data. So here's the specs of the LED. I copied them down there, but so basically what we have here, this is for constant current, this one right here. So at approximately 20 milliamps there, then I recorded the voltage on these too, and I also recorded the milliamps and the voltage out of the solar panel. So that's basically our control right there. That's the normal output of the LED. And then I was just seeing how much it could actually take at constant current before it would actually, the output would decrease. And at 100 milliamps approximately, it starts getting very hot, and it is at the output of the panel is at its maximum. And then once you get to 120 milliamps, the output actually stays about the same, and then 140, it gets very hot and the output is decreased. And I only tested these each for just to get them stable enough so I could take a reading. So it's not very accurate, but I just decided to, this was just a kind of experiment. Okay, so now here's where I'm pulsing it. So this is the current here. So we started, this one's actually backwards. So I started at 20 milliamps there at and the output of the panel, I don't have it marked there, but that's the milliamps out of the panel, is 0.6. It's a little off from oh no, it's about the same. And then I just went up from there, and at 1 amp, which is right here, 6.87 milliamps out on the panel, and that's about what I'm actually getting 5. It's almost 6 right here. So, although it's a little bit less current. In fact, the camera doesn't like this screen too much. Yeah. First time recording with my new camera, so. So yeah, it has about, from the normal output of the LED, I'm actually overdriving it about 70 times. So yeah, a lot, and it still works. And then the output is only increased at its peak from the control at 20 milliamps. The output is only increased about 11 times. So really, you lose a lot of efficiency there. So while it works to increase it as a flash or pulse an LED like that, and you can run it like that, it may not last for very long, but it will run, and you can get a lot more light out of it. 11 times more light, it does use a lot more current. So if you want more light, You may be able to increase it up to maybe like 40 milliamps or something like that, or maybe even 80 at a pulse, or maybe 100, but I wouldn't go for an amp, because then you lose the efficiency a lot, and you're risking burning out your LED. So that pretty much sums it up. So you can pulse things. LEDs, you can pulse them, but it's not real practical, I guess you could say, if you want more light output, because the average light output, you still can't go over the, because it can still only, no matter what you do to pulse it, you can still only get rid of a certain amount of heat. So it's rated at a certain amount of heat that it can get rid of, and it was reaching that right here. So between when the pulse is off, it's cooling down, and then once it gets back to here, it's cooled down so much that it can get that full pulse till it heats up again, and then once it starts heating up, it starts going downhill, the output. So yeah, but I mean, like something like a flash tube, a xenon flash tube, they're only pulsed for a very, very short time at a very high current, but because it's such a short time, it doesn't really it might get warm. So like if I put an arc through it for 30 seconds, it might get pretty hot. So yeah, that's about it. I hope you liked this video, and hope the quality's pretty good for you. Hopefully I can edit it without too much trouble. I'm not sure how much the quality is gonna affect my computer, but yeah. I guess I could turn the current down here a bit and show you what it looks like when it's only drawing like 100 milliamps or something like that. Although I'm gonna have to readjust my scope and all, so this might actually take a minute or two. So this is a really nice scope. I really like it. Let me just turn this current down to about 100 milliamps. Oh, we lost signal there. Okay, there we go. So the trigger wasn't triggering. Now let me turn my pulse width up a bunch. What is it doing? Oh my goodness. Okay, turn this. Alright, so there you can see a couple of waveforms there. And see, even at 100 milliamps, there's a drop. So it's still at 100 milliamps. You can see a lot more output because it's at about 50% duty cycle there. Maybe not quite. Turn it up a little bit. Alright, so that's about 50% duty cycle at 100 milliamps. But it will do 100 milliamps constant. Let me just take a reference there. And as you can see, as you increase the duty cycle, it starts dropping the whole thing because it doesn't have enough time to cool down in between pulses. So as you can see there, it's dropping. There we go. Alright, so that's full 100% duty cycle on. Okay, so 100% duty cycle, and it's dropped a lot from that first pulse there where it's cold. So it's cold. It has a lot. You can get a lot of current or a lot of output. Still the same current. The current really doesn't drop. And I haven't actually had any LEDs actually go thermal runaway yet. But it's getting fairly warm, and the output is quite good at 100 milliamps, but it probably wouldn't last long, probably because the heat just can't get out of the LED. But that's about it. So go check out Bake Up CPU, link in the description. Tell me what you think, and that's about it. Thanks for watching.